Hi everyone, welcome to our presentation. We, the students from Chemistry Department, Sacred Heart College, Thevara, are gonna take a small portion coming under the section Nuclear Physics. Our topic is properties of alpha, beta and gamma radiations. First of all, let me introduce you the group members. Gopika Gopakumar, Alanta Maria, Sonat Biju, Malavika Madhu and myself Aiswariya will be dealing today's session. So let's begin our presentation. At first, we can have a small discussion on the topic radioactivity and the salient features concerned with radioactivity. So, what is radioactivity? As its name implies, radioactivity is the act of emitting radiation spontaneously. And this is done by an atomic nucleus that for some reason is unstable. That means it wants to give up some energy in order to shift to a more stable configuration. Or in short, you can say that radioactivity is the process by which an unstable nucleus loses energy by emitting radiation. And radioactivity is also known as radioactive decay, nuclear disintegration, or radioactive disintegration. While there are many forms of electromagnetic radiation, they are not always produced by radioactivity. For example, a light bulb may emit radiation in the forms of heat and light, yet it is not radioactive. Thus, we can consider that a substance that contains unstable atomic nuclei is considered to be radioactive. While radioactivity results in the release of radiation, not all radiation is produced by the radioactive material. And the SI unit of radioactivity is becquerel, and it is important to note that this unit is named in honor of the discoverer of radioactivity, the famous French scientist Henri Becquerel. Let us know some more about Henri Becquerel. Antoine Henri Becquerel was born on 15th December 1852 in France. He was a French engineer, physicist, Nobel laureate and the first person to discover the evidence of radioactivity, and this was done in the year 1896. For work in the field of radioactivity, Becquerel, along with Marie Curie and her husband Pierre Curie, received the Nobel Prize in Physics in 1903. Even though Henri Becquerel was the first person to discover the evidence of radioactivity, but the term radioactivity was actually coined by Marie Curie. Here comes another scientist, Ernst Rutherford. Ernst Rutherford did many experiments on studying the properties of radioactive decay. And finally, he was able to classify the types of radiations on the basis of their penetrative ability and electrical charge. And these were classified as alpha, beta, and gamma radiations. Ernst Rutherford identified the nature of alpha and beta radiations, and he connected the first alpha radiations to helium and later on identified them to helium nuclei after his discovery of the atom nucleus. Moreover, he also interpreted the emission of beta particles as the emission of electrons discovered a few years before. Thus, finally, in 1902, Rutherford was able to show that a change in the nature of atom occurred during the emission of alpha and beta rays. That means the atoms were found to be transmuting. Even before that, in 1900, another scientist, Paul Willard, found that gamma rays were simply high energy photons and of the same type as X rays. So it was after Paul Willard's discovery that in 1903 Ernst Rutherford was able to name this radiation as gamma rays based on their relatively strong penetration of matter. So that's all regarding the portions coming under radioactivity. Now my friend Gopika will be talking to you on the properties of alpha particles.
Warm good evening to all. Good evening, Dr. Pius Augustine and my dear fellows. I'm Gopika Gopakumar, second member of this group. First of all, I thank my friend Aiswariya for having a very wonderful introduction on our topic. So without much more, we are moving on to the topic alpha particles. What do you mean by this alpha particles? Alpha particles are nothing but helium nuclei. So before that, do you know who discovered this alpha particles? These alpha particles are discovered by the great scientist Ernest Rutherford in 1899 while he was having investigations on radioactivity. And later in 1907, he confirmed that these alpha particles are nothing but helium nuclei. So to be very precise, we can say that alpha particles are helium ions carrying 2 units of positive charge. So moving on to the properties of helium nuclei or this alpha particles in detail. First property. These are positively charged particles, hence it get deflected towards the negatively charged plate. So since being a positively charged particle, when it is acted upon by an external electric field, it will be definitely get deflected towards a negatively charged plate. As I said earlier, these alpha particles are helium nuclei. So it consists of 2 protons and 2 neutrons. Next is, it get deflected by both electric and magnetic field. Since being a charged particle, it will get deflected by electric and magnetic field. When it is acted upon by an external electric field, it will be acted upon by the electric field force, and when it is acted upon by an external magnetic field, the external magnetic Lorentz force acts on the particle and hence it get deflected in the external magnetic field. So next is regarding the velocity of alpha particles. Generally, alpha particles has very high velocity and it depends upon the source of emission. That is, depending upon the atom or the nuclei from which it is emitted, the velocity of alpha particles varies. In general, we can say that alpha particles moves with very high velocity. Next is the ionizing power. The alpha particles has very high ionizing power when compared to beta. It definitely ionizes the gas through which it passes. Next is regarding the penetrating power of alpha particles. Even though alpha particles has good penetrating power, when compared to beta, it has a low penetrating power. The range of penetration of alpha particle is from 2.7 cm to 8.62 cm of air, which is indeed a smaller value when compared to that of beta particles and gamma rays. Next is regarding the photographic plates. This alpha particles affects the photographic plates because these photographic plates are coated with salts of silver and these alpha particles are charged particle. So it definitely affects the photographic plates. Next is that the alpha particles produce fluorescence and phosphorescence. What do you mean by this fluorescence and phosphorescence? Fluorescence is the emission of light by a substance that has absorbed light or any other electromagnetic radiation. So, the fluorescence is the re-emission of light or electromagnetic radiation by a substance after absorbing the electromagnetic radiation. So alpha particle is one among the particles that shows fluorescence. Next is a phosphorescence. Phosphorescence is a chemical property. It is the emission of light after a particular type of chemical reaction where the excess chemical energy is given off as light. So after a particular chemical reaction, if there is excess of chemical energy, in certain reactions this excess chemical energy will be converted to light energy. This property or this phenomenon is known as phosphorescence. So alpha particles exhibit both fluorescence and phosphorescence. Next is the range of alpha particles. So what do you mean by the range of alpha particles? The range of an alpha particle is defined as the distance traveled by alpha particle in a medium before it get completely stopped or completely losing its ionization power. So as I said earlier, the alpha particles has high ionizing power and they move with very high velocity through a medium. So when it is moving through a medium, after a particular time, its velocity drops to 0 and it loses its ionization power. So before getting before dropping the velocity to zero or before losing its ionization power completely, how much distance the alpha particle has traveled. That distance is referred to as the range of alpha particles. Next is alpha decay. So as we know, alpha decay is one among the important radioactive disintegrations taking place in nature, and this alpha decay is one of the major reasons for the existence of alpha particles in nature. So what do you mean by this alpha decay? The alpha decay is a type of radioactive decay in which the parent nuclei disintegrates into a daughter nuclei and an alpha particle. So we can illustrate the alpha particle with alpha decay with an example. Here, radium, which is having an atomic number 88 and mass number 226, undergoes an alpha decay, and a new daughter nuclei called radon is formed, which is having an atomic number 86 and mass number 222 and a helium nuclei or an alpha particle. So here, when radium undergoes alpha decay, it is completely getting transformed into another nuclei or another radioactive element, which is radon. So how this happens? This is because during alpha decay, a helium nuclei or an alpha particle which is having a proton number 2 and mass number 4 will be emitted from the nucleus. So the atomic number of the parent nuclei decreases by 2 and mass number decreases by 4. Hence, after an alpha decay, an entirely different daughter nuclei will be formed, which is having an atomic number 2 less than the parent nuclei and mass number 4 less than the parent nuclei. So after alpha decay of an atom, its atomic number decreases by 2 and mass number by 4. Let us illustrate the alpha decay with a general example. That is, using a general formula, which is XZA gives YZ minus 2A minus 4 plus helium 2,4, where X is the parent nucleus, which is having an atomic number Z and mass number A, get transformed into a new nuclei, which is the daughter nuclei called Y, which is having an atomic number Z minus 2 and A minus 4. That is 2 less than the atomic number of the parent nuclei and 4 less than the mass number of the parent nuclei and an alpha particle. So we are moving on to the end of my topic, that is alpha decay increases the stability. Why alpha decay increases the stability of a species? This is nothing but because of the reduction of mass number. So as I said earlier, after an alpha decay, the mass number of the parent nuclei decreases by 4. As mass number decreases, stability increases. So the alpha decay results in an increased stability of an atomic species due to the reduction in mass number. And any nuclei having a mass number greater than 210 undergoes alpha decay. So that's all about my session. Thank you. Thank you for listening to me.
Hello everybody. Today we are moving to the next topic, that is properties of beta particles. Before going to the properties of beta particles, let me discuss about what is beta particles. Beta particles are also called as beta ray or beta radiation. Is a high energy, high speed electron or positron emitted by the radioactive decay of an atomic nucleus during the process of beta decay. This is clear that a beta particle is a positron or electron, which is a byproduct of a radioactive decay of an atomic nucleus. Since the process is the product formed is beta particles, it is called a beta decay. There are two types of beta decay, beta minus decay and beta plus decay, which produce electrons and positrons respectively. That means beta minus decay results in the production of electrons, whereas beta plus decay results in the production of positrons respectively. Now let us discuss about beta decay. First of all, beta minus decay. A neutron in the nucleus decays into a proton, electron and antineutrino. It's clear that a neutron is decayed into a a proton, electron and an antineutrino. The electron and antineutrino are emitted while the proton remains in the nucleus. Therefore, since the proton remains in the nucleus, the atomic number increases by 1 unit, and the other two products released, electron and antineutrino, are emitted out. The equation below shows it clearly. When iodine decays into xenon, the atomic number increases by 1 unit with the emission of 1 electron, that is beta minus particle. Then we are moving to beta plus decay. A proton in the nucleus decays into a neutrino, a positron, and a neutrino. The positron and the neutrino are emitted while the neutron remains in the nucleus. Since the neutron remains in the nucleus, the atomic number decreases by 1 unit, while the positron and neutrino are emitted. Now, check into the equation given below. In this equation, when the magnesium is decayed into sodium, the atomic number decreases by 1 unit and a positron and a neutrino are emitted. In this table, we can clearly distinguish between beta minus decay and beta plus decay. Okay, I hope you all understood. Now moving to the next particle. Properties of a beta particles. Beta particles are identical to electrons since they have a mass that is equal to that of an electron, that is 9.1 into 10 raised to minus 31 kilogram. It carries a negative charge. High energy, high speed electrons or positrons. See, we had already discussed it in our early topic that beta particles are high energy, high speed electrons or positrons formed as a result of beta decay. It consists of electrons moving with high velocities. It produces fluorescence and phosphorescence. It affects the photographic plates. That is, the beta particles are more radioactive and energetic than alpha particles, so their effect on photographic plate is more. I hope you all understood that. Next property is it is deflected by electric and magnetic fields. Because of its lower mass, it suffers more deflection in the magnetic field. Next property, penetration power. That is, it penetrates the matter through which it passes, is higher than that of alpha particles since it is more radioactive. Last property, ionized gas through which they pass. The ionizing power is less than that of alpha particles, that is 1 by 100 the times of that of an alpha particles. That was end of my section. Now I invite Sonat to continue the presentation. Thank you everyone.
Hello everyone. First of all, I sincerely appreciate Alanta for sharing her ideas about beta rays and its properties. Now, we are moving on to our next session, gamma radiations and its properties. Gamma rays. A gamma ray or gamma radiation is a penetrating form of electromagnetic radiation arising from the radioactive decay of atomic nuclei. It consists of the shortest wavelength electromagnetic waves and so imparts the highest photon energy. Now, let us discuss gamma rays in detail. The waves arising from the high frequency end of the electromagnetic spectrum that has no mass are known as gamma rays. Gamma rays are at the extremity of the spectrum and they are having high energy photons. They are having a high penetrating power, which there is a penetrating range of about 30 cm of an iron rod. Gamma rays are ionizing radiation and can ionize other atoms. Gamma rays cannot be reflected off a mirror
and their wavelengths are so small that they will pass between atoms in a detector. That is, wavelength of gamma rays is about 10 raised to minus 13 meter approximately. Gamma rays are very dangerous if you are directly exposed to them. Moving on to the properties of gamma rays. Gamma rays are electromagnetic waves with very large energy, and they have a wavelength of about 0.01 angstrom. Gamma rays are not deflected by electric and magnetic fields. This indicates that they have no charge. Gamma rays travel with the speed of light, that is about 3 into 10 raised to 8 meter per second. Speaking of the penetrating power of gamma rays is much more than that of alpha and beta particles. They can pass through 30 centimeter thick iron sheet. A question can be asked from this section: why do we usually use isotopes emitting gamma radiations as radioactive tracers in medical use? This is because gamma rays are high energetic and much more penetrating, while alpha particles are not used in radiotherapy because their penetrating power is very low and cannot penetrate through human skin. Moving on to the next property. Gamma rays ionize gases, but their ionization power is very small compared to that of alpha and beta particles. Gamma rays produce fluorescence. They affect photographic plates more than that of beta particles. They are diffracted by crystals in the same way as X-rays. Gamma rays are absorbed by substances and give rise to the phenomenon of pair production. Pair production is a process that results in the conversion of a photon into an electron-positron pair. When a gamma ray photon strikes the nucleus of some atom, its energy is converted into an electron and a positron. That's all about properties of gamma rays. Now, we are moving on to the last topic, gamma decay and its salient features. What is meant by gamma decay? Gamma decay is one type of radioactive decay that a nucleus can undergo. What separates this type of decay process from alpha or beta decay is that no particles are ejected from the nucleus when it undergoes this type of decay. Instead, a high energy form of electromagnetic radiation, a gamma ray photon, is released. Gamma ray occurs when there is too much energy in the nucleus of an atom, causing it to emit a gamma ray without changing its charge or mass composition. In gamma decay, a nucleus changes from a higher energy state to a lower energy state through the emission of electromagnetic radiations or photons. The number of protons and neutrons in the nucleus does not change in this process, so the parent and daughter atoms have the same chemical element. This brings me to the end of my presentation. Thank you so much for your interest and attention. Now here is Malavika to continue with the presentation.
Thank you, Sonat. That was really a nice presentation. Hello everyone, myself Malavika Madhu. In this section, we are going to discuss about these 3 points: comparison between alpha, beta and gamma rays, uses of nuclear radiations and their harmful effects. So let's move on to the last section of this seminar. What is an alpha particle? As we all know that an alpha particle is the nucleus of helium-4 atom with a positive charge of 3.2 into 10 raised to minus 19 coulomb and which has a rest mass which is approximately equal to 4 AMU. A beta particle is a fast-moving electron having a negative charge of 1.6 into 10 raised to minus 19 coulomb and has a rest mass which is equal to the rest mass of an electron, which is given by 0.00549 AMU. Gamma rays. Gamma rays are entirely different from alpha and beta particles. They are electromagnetic waves of short wavelengths and does not have any charge or mass. It travels with a velocity which is equal to the velocity of light, given by 3 into 10 raised to 8 meter per second. The beta particle has a velocity which is 0.99 times the velocity of light. The alpha particle has the least velocity which is 1 by 10 the velocity of light. Penetrating power. While dealing with the properties of radiations, the most important property is their penetrating power. Because based on the difference in penetrating power, this radiation has many uses in various fields. The penetrating power for alpha particle is very low, and for gamma rays it is very high, and beta particle has a penetrating range which is in between that of alpha and that of gamma. The ionization of alpha particles in air is very high, and that of beta particle it is 1 by 100 of alpha, and gamma rays it is very least 1 by 100 that of beta. The alpha and beta particles undergoes deflection in electric and magnetic field. In electric field, the alpha particles deviate towards the negative plate since it is positively charged, while the beta particles deflects towards the positive plate since it is negatively charged. The gamma rays does not undergo any deflection since they don't have any charge. These three radiations also affect the photographic plates and also produces fluorescence. As we all know that fluorescence is the emission of electromagnetic radiation, usually visible light caused by the excitation of atom in a material. Moving on to the next topic, penetrating range. From this picture, it is very evident that the alpha particle has the least penetrating range, which is about 2.7 cm to 8.62 cm of air. And the beta particle could able to penetrate through an aluminium sheet of 5 mm or a lead sheet of 1 mm. The gamma radiation has the highest penetrating range, which is 30 cm of iron. Since the gamma radiation has the highest penetrating range or penetrating power, in nuclear reactors they use lead or concrete walls in order to prevent the radiations from escaping. Next topic, uses of nuclear radiations. The use of radiations and nuclear techniques in medicine, industry, agriculture, energy, and other scientific and technological fields has brought tremendous benefit to our society. The benefit in medicine for diagnosis and treatment in terms of human life saved are enormous. Now, let's see some of the examples of its application. First one, radiotherapy. In radiotherapy, gamma radiations are used which kills or slows down the growth of cancer cells. Radiotherapy can treat overactive thyroid glands also. But in radiotherapy, we can't use alpha particles or alpha rays. Why? Because as we all know that the alpha particle has very low penetrating power, so that it can't penetrate through our skin. Next one, tracers. Tracers are used for the diagnosis of cancer, tumors, and many other diseases. Generally, beta and gamma can be used as tracers. Next one, smoke detector. Smoke detector emits a constant stream of alpha particles, and a sensor detects these alpha particles, causing a small current. If a smoke particle comes in between the source and the detector, the current decreases and it starts alarming. Gamma radiations are also used for the sterilization of hospital equipments and also used to kill insects and bacteria from food before it is packed. The food irradiation doesn't make food radioactive. Instead, the radiant energy just passes through the food, so the food is safe to eat. The next topic, harmful effects of radiations. Radiations, when exposed to large amount, can destroy living cells, produce gene mutation and cancer. When a nuclear bomb explodes, it mainly produces X-rays and gamma rays. The disaster caused by nuclear radiations in Hiroshima is one of the examples for the dangerous nature and long-term effects of radiations. About 1,66,000 people were killed by the X-rays and gamma rays produced as a result of this bomb explosion. Have you heard about Chernobyl nuclear disaster? It is considered as the worst nuclear disaster in the history of the world, which happened in Ukraine in 1986. This accident destroyed the Chernobyl 4 reactor, killing 30 operators and firemen within 3 months, and several further deaths later. The accident caused the largest uncontrolled radioactive release into the environment. An area of more than 4,000 square kilometers has been abandoned then, and the radiations are still prevailing there even 34 years after the disaster. But now it is a tourist place and tourists are allowed to visit the site under very strict safety measures. As the exposure to radioactive material is severe and bears grave consequences, so radioactive pollution is mandatory. Through appropriate safeguards and control measures, we can prevent or at least minimize the adverse environmental impacts. It is only through prevention that safety can be assured. The regulations and other standards should be put in place to make sure that there is no way for radioactive matters to be released. That's all for our presentation. Hope you guys understood what we were trying to convey through this seminar. Now, I use this time to convey our sincere gratitude to Dr. Pius Augustine, our mentor, for giving us such a wonderful opportunity. Thank you.